Chapter 8 digs a little deeper into queries. Queries are used to collect or gather records from a map or table. The results meet specified criteria. With ArcMap, you can query both aspatial and spatial criterion. Queries can be used to select features of interest. In this case, we're looking for coverage type TAA, which represents stands of aspens. Once you have all the aspen stands selected, you can look at the statistics to know exactly how much area of aspen stands are available. By selecting those stands, you can now look closely for any patterns. Are they randomly scattered or clustered? You add more criterion to learn more about the aspens. In this case, we'll query to find mature large trees with open crowns. Look at the data, and asking spatial relationships is where ArcMap excels over traditional database management systems. Now we can see and select which aspen stands have a road passing through them. When working with rasters, you can query based on pixel values. Shown here are digital elevation models, and you can select those pixels that are above 1500 meters in elevation. We talked about attribute queries in previous chapters. Select by attributes is the tools used to initiate the attribute query. Attribute queries require SQL language, and ArcMap has a nice interface that helps us construct the SQL statements by point, pick, and click. Examples of queries. Can you understand what they're all asking for? Queries are used to extract records based on given criteria. Consider this pool of data where the circle of T represents all of the university. The circle A represents students from New York. The circle B represents geography majors. Select the students from T where home state equals New York will return the circle A. Select students from T where major equals geography would select the B circle. Select students from T whose home state equals New York or major equals geography would select both A and B circles. Select students from T whose home state equals New York and major equals geography will only select the areas where A and B overlap. It is important to understand the differences between and or. Both conditions are tested separately. When and is used, both conditions must be true. When or is used, either condition may be true. Boolean operators are used to evaluate pairs of conditions. Remember, for and, both conditions must be true, and for or, either condition can be true. This query selects from the population T only those students from New York that are geography majors. Both conditions are true. In this case, both circles A and B are selected. The A is for those from New York, while the B are for the population of geography majors. First, you are looking for the students in T from New York and have a GPA greater than 3.0. The results of both conditions must be true. The result is the area of overlap between the circles A and B. Advanced Boolean include XOR and NOT. Spend a few minutes thinking about AND, OR, XOR, and NOT. These illustrations show the results from these operators. The operators AND, OR, and XOR are commutative, which means the order of condition doesn't matter. The results will be the same regardless of which condition is first. However, NOT is not commutative, and the order of conditions is important. The Boolean operators have equal order of precedence. The expressions are evaluated from left to right, and to change the order, you can use parentheses. Be careful when entering your expressions. A common mistake is to use AND operator looking for two values in the same field. That can't happen. There are no records where land use is equal to residential and equal to commercial. You need the OR operator in this case. In this example, the rectangles below represent parcels of land. Their value is noted, and the pink ones are residential while the green ones are commercial. Looking at the first query, which parcels are selected? The four large rectangles along the bottom are those over 100,000. What about the second statement? The two large bottom green rectangles are selected by the conditions inside the parentheses, and all the pink rectangles are selected by the OR LU equals RES statement. When searching text strings, you can use the wildcards, which are normally asterisks or percent symbols. The like operators help search partial text strings, again using wildcard placeholders. Remember, SQL statements are case sensitive. Spatial queries help us locate items based on their location on the planet and their relationship to other things. There are three principal spatial relationships: intersection, containment, and proximity. Additional operators can be used to fine-tune the spatial queries. In this case, we want to select aspen stands that are intersected by roads. Terminology always comes into play. Know that the target layer is the one that contains the items that or features that you want to select, aspen stands in this case. The source layer is the one containing the features being compared to, the roads layer in this case. The intersection option includes all touching, crossing, and overlapping and other features. There are special cases that can be applied to further limit the selected items. Contain means features that enclose all of another feature. Within is the inverse of contain. Again, there are special cases to refine the selection. This slide helps to better explain containment. For example, the state of Oregon contains the county of Columbia. They share a boundary. The state of Oregon completely contains the county Jefferson. Again, within is the inverse or exact opposite of contain. Columbia County is within Oregon. Jefferson County is completely within Oregon. Proximity operators are used to select features within a certain distance of. In this first example, we can select the counties, targets, which contain state capitals, source. The second image uses a proximity to select all the counties, the targets, that are within 200 miles of Denver, the source. In this first example, we can select the counties that intersect rivers. The second image, we select all the rivers that intersect Texas. In the first example, we can use proximity to select cities that are within 20 miles of an interstate. The second image requires two queries. First, use an attribute query to select counties named Washington, then use a spatial query to select all the cities that are within the selected Washington counties. The next few slides demonstrate general information about queries. There are three ways to select features using ArcMap. 1. Interactive selection means you use the mouse to pick them from the map or table. 2. Select by attributes by querying the attribute table. 3. Select by location by using a spatial query. The end result is exactly the same, regardless of how you select the features. The features are highlighted, selected, and ready for further processing. When selecting interactively, you want to pay attention to the list by section view in the table of contents. Features are selected for each layer and set the layer to be selectable or not selectable. List by select view on the table of contents gives you a lot of control for interactive selecting. Selected features are highlighted in both the map and attribute table. There are a number of ways to clear your selected features from the attribute table toolbar, from the list by selection view on the table of contents, or from the tools toolbar, from the selection pull-down menu, and the selections tools from the context menu when you right-click a layer. Interactive selecting is manually picking features from the map or table with your mouse. There are a set of selection tools you can use to interactively select features. Select by rectangle is the default. Using the List by Selection view of the table of contents, you can toggle the selectability of a layer on and off. From the Selection pull-down menu, you can pick Select by Graphics, then draw graphics from the Draw toolbar to select features. Queries are used to select by attributes and select by location. If you pick Select by Attributes from the Selection pull-down menu, you will need to specify which layer you want to query. When you choose Select by Location from the Selection pull-down menu, you will need to determine a method, target layer or layers, the source layer, and the spatial operator. In this example, we're selecting counties, the target layer, that intersect rivers, source layer. Here we select cities that are within a distance of 15 miles from rivers. In this case, Texas is previously selected, and now we can select rivers that are our target that intersect states. But notice the checkbox, Use Selected Features. That means only rivers that intersect Texas will be selected. Here, Missouri is previously selected, and we use the Select by Location to pick states, our target layers, that intersect states, our source layer. Since the Selected Features is checked, the source is only Missouri. Select Method is very important and will help you, so pay attention to that option at the top of the dialog boxes. The basic methods are Create a new selection, which is the default, Add to current selection, Remove from current selection, and Select from current selection. Think about these descriptions. They work exactly like they say. Using different selection methods is exactly like using the Boolean operators. Pay attention to the selection method and use it to help achieve your goals. The real benefit is when you can combine the selection methods to solve real problems. In this case, FEMA needs help determining where to distribute funding for earthquake relief. The criteria is that cities must have a population greater than 500,000 and they must be within 50 miles of an earthquake. In this case, both criteria must be true, so this is an AND case. We can start by selecting the cities that are within a distance of 50 miles from earthquakes. The population data is stored in the attribute table, so we must select by attributes next. The method is very important here because we only want to search through through the previously selected cities. The method in this case must be select from currently selected. The criteria is population greater than 500,000. The results are the cities that should receive the funding. Most analysis require multiple steps, so you want to create subsets as you go. In many cases, you'll want to create a layer from the selected features. This adds another layer to your data frame, which only includes those features that were selected. Features that were selected. This new layer is not stored externally and really still contains all the other features that are not shown. It's great for creating symbols to display on your map, but if you want to further process, consider exporting the selected features. When you export selected features, you actually create another file that is only storing those features which were selected when you exported. To export your selection, right-click on the layer you're wanting to export and pick Data, Export Data. Definition queries are properties of a layer. They are used to limit what is displayed. If you have any questions, give me a call or send me an email. Thanks.